Let's discuss question number 17 from test 1. This is from fluid mechanics. It's a question on impact of jets. A jet of water ejects from a nozzle and strike. So this velocity is 20 meters. So water coming out is 20 meters. It impinges normally on a flat plate which is moving again with 10 meters per second. Okay, so this is how it goes and it combats, but only thing is both are moving, both the jet and the jet is moving with a high velocity, so it impacts the plate which is also moving with velocity but a lower velocity. So this is how the water comes out. Okay, so now the cross-sectional area is given as area of cross section is 0.02 meter square. The density of the water is given as 1000 kg per meter cube. Now in this kind of problems, when both the jet has a velocity as well as your vane has a velocity, it is better to use a relative coordinate system. So I just take a relative coordinate system where I assume that the vane is moving. So when I assume that this is stationary, so I solve this in a relative coordinate system attached to the frame, attached to the coordinate attached to the plate. So when I consider that, so now the jet would be moving something like this. This is stationary, so this velocity will be v minus u, the relative velocity. So I am just solving everything in relative sense now. So now, so let's solve this. So before applying the impulse momentum, let's draw our control volume. So this was v minus u, and you have some velocity here and here, but this doesn't have any horizontal velocity, and this is the force that is exerted by the plate onto the stream of water. So the same force will be exerted by the water on the plate, and this is what we need to find. This is from Newton's third law. Okay, so this is from Newton's third law. So now I just take, this is my control volume and the force that is acting is F. So I apply the Newton's impulse momentum, which it says that summation of all the forces in its direction is mass flow rate into the final horizontal velocity minus initial in that direction. So sum of all the forces in its will be basically the change in momentum in its direction, and this is at the outlet, this is at the inlet. Okay, so force is acting, we have considered this direction as positive. Force is acting from the plate. Now remember, when you are drawing the control volume or the free body diagram, you have to consider the forces that is exerted on this body because of the other body. So F is minus F because it's acting from the plate, minus F. M dot outer velocity in the x direction is 0 because it has only in the upward direction, y direction, minus initial velocity inlet is in this direction, so minus, it is v minus u. So this is minus m dot v minus u is minus F, or the force exerted is m dot v minus u. Now how I get m dot? M dot is mass flow rate, which is density, into volume flow rate. Volume flow rate is area into v minus u, because we are working everything in the relative frame, so volume will be v minus u. So this comes out to be rho a v minus u whole square. Density is given as 1000, area of cross section is 0.02, v is 20, this is 10, so this comes out to be 10 cube into 0.02 into 10 whole square, which is 100. So this comes out to be 2000 newtons. So the force that is exerted by the flow stream onto the plate is F, which is 2000 newtons. So normally what we do is we consider the control volume attached to the control volume, or basically we work in the relative coordinate system when the vane is moving. So that's what we have done, and everything will be in terms of relative velocity, and we have found out the force that is exerted on the plate. So 2000 is the answer. Option is D. Thank you.